acids are formulas that start with hydrogen, so you're going to see that every time we have an acid, it begins with hydrogen. Now, there are two very important exceptions. And these two exceptions are things that you're already familiar with. One is water. Okay. The other one is H2O2, and you probably have this in a brown bottle in your medicine cabinet at home. That's hydrogen peroxide. So those two do not have acidic properties, but they do start with hydrogen. And acids are sort of an in-between type species. If the compound is formed and there's no water present, then it's molecular, but as soon as you put it in water, it forms ions. So knowing whether it's ionic or molecular isn't really that important because the naming system is separate for acids. Okay, and these are mostly going to look like ionic compounds to you, and you're going to see we use the term anion with them. So the name of the acid depends on the anion that it's with. So you'll always be looking at the second part of the compound first when you're doing the name. So it's a little backwards in comparison to naming standard ionic compounds and molecular compounds. Okay, it's, three anion endings that you've seen thus far are "ide," the IDE, ITE, and ATE, and each of those is going to determine a different type of acid name. So if you remember, all acids start with hydrogen, as I said earlier, and we're going to be looking at the stem. So probably a familiar acid to you might be this one. So HCl is stomach acid. That's what burns when you vomit, and why your mouth feels kind of icky after a while if you vomited, because you actually have acid burn inside your mouth, and it takes a while for your skin to regenerate to heal that. So if we look at the anion part of this acid, first we know that Cl by itself is chloride. So the stem part of that is usually what's in front of the IDE. So you're going to see from the little chart I have here then HCl is named hydrochloric acid. And the thing you'll find out is the shortest formulas have the longest names. So the word acid comes from the first part of our formula, which is hydrogen. So acid tells us it's hydrogen. Hydrochloric tells us it comes from chloride. Another acid you might be familiar with is citric acid. If you love Sour Patch Kids, lemons, oranges all have citric acid in them. So we'll work backwards this time. If it's citric acid, you're going to see IC with no hydro this time. So IC comes from your 8s. So again, IC is going to turn you around in here into your 8 acid. So this is going to come from citrate. Okay. So you're going to have a formula with hydrogen and then citrate. So hydrogen being a charge of +1, so even though it's not an alkali metal, it's in group 1A, and most of the time it does act as an acid with a hydrogen being positive. And then citrate, which is that messy one, C6H5O7, which is a -3. So from this perspective, they are exactly like ionic compounds. With charges, you're going to crisscross and reduce, and this is going to give you H3C6H5O7. Okay, if you haven't written down the anion ending and the acid name yet, please pause the video and do so now, because you're not going to see that on the next screen when I go through the next couple examples. The other rule that you have is with the ITE ending. So if we pull an ion like nitrite, which is NO2 negative, and put that with hydrogen, we get nitrous acid. So again, you take the ITE off and add OUS. Okay, and you can put pretty much hydrogen with any anion and get an acid, with the exception of a OH. So HOH, when you put that together, is just another way to write water, and that one's not an acid. The other thing I have on the screen are two kind of little stupid sentences, but hopefully these will help you to memorize the rules for naming acids. So the first one is, I hide in the hydroelectric plant. I don't advocate that you ever try that, since a hydroelectric plant is where you have a lot of river water flowing over a dam, so that wouldn't be safe. But you do see your IDE ending, okay, here, and you see your prefix hydro with ic here as well. When we get to the White House gate is thick, you're going to see the ITE ending, okay, and the OUS together, so the White House. So, okay, so the ITE and OUS go together, and when you get to the second part, you have ATE and IC. So those two, the thick gate, also go together, which gives you your ATE and ITE ending. Okay. So these two sentences will help you with the rules for naming acids. Now, I do want to talk to you about two exceptions. You might be familiar with sulfuric acid, which is battery acid. You'll see that IC ending, so you think of adding the ATE back in. So it's not, you're not going to find any ion on your list that is sulfurate. So with sulfur and phosphorus, the anions don't have the UR and the OR respectively in their names, but the acids do, and they just do that because sulfic acid sort of sounds pretty harsh. Sounds like a German yelling at you. But sulfuric flows a little bit better, so you have to be a little bit careful with that one. So sulfuric acid comes from sulfate. So again, the ATE and IC go together, and when you're writing the ions out, hydrogen's a +1 and sulfate's a -2, crisscross and reduce, and you get H2SO4. Okay. Likewise with phosphate. Okay, with phosphate, if we're putting that together with hydrogen, you're going to have H plus and PO4 -3. Again, you're going to do your crisscross, and you get H3PO4. And again, least common multiple works. You need +3 and -3. And then its name is phosphoric acid. So again, adding that OR in to get your flow right for the names. Okay, at this point you've had lots of experience with different ions. I'm going to introduce extending the periodic table beyond and the ion sheet beyond what you know. So by having this base memorization of all of these ions, we can add more to it from the periodic table. And we're going to focus on the family known as the halogens. So again, this group here, these are the halogens. I think we had pretty much everything else labeled on your table except for those. So you may want to pull out that periodic table that has the group names on it, pause this recording, and label the halogens. And I think most of you knew these, but while we're doing the labeling, I want to include these as well. These are your noble gases. Okay. So what you should know about things that are in the same vertical group or family is that they have the same chemical properties. So on your ion list, you have a whole bunch of ions that have chlorine in it. We're going to basically extend that to any of the other groups. So you're going to see on the next page where I'm going to do a whole model of one and then give you some random ones. Okay, if we look at your green sheet, you have the whole family of oxychlorine ions. So they all have different numbers of oxygen, but it's all chlorine and oxygen. And again, you have all of these names: hypochlorite, chlorite, chlorate, and perchlorate. Any other halogen is going to form all of the same ions. So any place we have chlorine, we could substitute in fluorine. I just chose bromine, so you'll see I have the entire bromine group here. So the only thing that's going to change is really the stem. So we're going to replace, where every place I have chlor, I'm going to replace with bro. So this is hypobromite. Okay. This next one is going to be bromite. And BrO3 negative is going to be bromate. And this last one is going to be perbromate. So by knowing the ions that you do, which is a lot, you can extend it beyond that to come up with many more ions than you would have to memorize individually if you understand the groups on the periodic table. So if we put this into an acid, if we had something like bromous acid, okay, the OUS tells you it comes from bromite, so you just have to model after chlorite, and then you're going to get HBrO2 as your acid, because again they're +1 and -1 ions. Okay. If I go to fluoric acid, okay, just replacing fluor, so since it's an ick, it comes from fluorate. So instead of having Cl, where I have this here for chlorate, it's going to become fluorate. So this is going to be FO3, it's still going to be -1, and with hydrogen, it's just going to give you a formula of HFO3, and that is fluoric acid. If we go with another acid, something like selenic acid, okay, probably not anything you've ever heard before, but again, since it's an ick acid, that ending is going to tell you that it comes from the selenate ion. So again, whatever is with ATE is with oxygen, so if you look on the periodic table, you're going to find Se for selenium. And it's in the sulfur family, so since sulfate is SO4 -2, then selenate is going to be SeO4 -2. So when you put that with hydrogen, you're going to get H2SeO4 as the formula of your acid when you do your least common multiple or crisscross and reduce. So again, we're expanding the periodic table beyond what you are comfortable with. So let's do one more. If you had this one, this time we'll go the other direction. Okay, H3ASO4. There was no ASO4 on your list, but if you look at arsenic, it's in the same family as nitrogen and phosphorus. So we do have to be careful here. Nitrogen's a little bit of a unique one, but arsenic is going to be like phosphorus because it's in the same group as phosphorus. Okay, so PO4 is phosphate, so ASO4 is going to be arsenate. Okay, and again, because it's an ATE, this then becomes arsenic acid. So knowing what you know about periodic properties and all of this ions on the green sheet, you can really expand this to do a whole lot more than is even on that green sheet. Okay, you have a practice sheet on naming acids. Again, there is a lot of repetition because there's only so many acids, but hopefully you'll be very good at naming them.